Hey guys, welcome back to General Chemistry. Today we're going to dive into thermochemistry. So if you're in my class, this is going to be chapter 9. This first video is going to serve just as a definitions. So just getting to know energy, getting to know some of the terminology, and then the position that we take to study energy as chemists. So this chapter is just kind of an outline of where we're going with it. We're going to talk about energy basics. That's going to be the first couple lectures. Then we're going to talk about something called calorimetry, and then we'll end on this thing called enthalpy. So energy basics. Energy is defined as anything that has the capacity to do work or supply heat. So these definitions are going to be very physical or physics definitions, and my job is to try to apply them to chemistry. So how would we as chemists position ourselves? So energy is anything that has the capacity to do work. That's a tough one for chemists. We tend to think about kind of the second half of this definition as energy is anything that has the capacity to supply heat. Why is work a tough one? Well, let's look at the definition for work. Work is a force acting over a distance. So if I wanted to push a chair across the room, I would apply a force to that chair. That chair would move over a distance, and I have done work. The energy needed to apply that force or to move that chair would be the energy stored in my muscles. So as I applied that force with my muscles, that was the energy that was able to do that work. Looking at how things move over a distance is a little bit difficult at first in chemistry. So when we first dive into this definition of energy in chemistry, we tend to think about the second half of that, something that has the ability to supply heat. So heat is the flow of energy caused by a difference in temperature. So it's not the temperature itself that is the heat, but it's that flow of energy based on the difference in temperature. So much of this chapter, we are going to focus on this heat piece. When we talk about energy, we kind of synonymously use the word heat. All right, if we want to break down energy a little bit further, we can break down energy into kinetic and then eventual potential energy. So if you've taken any physical science class or physics class, you know that kinetic energy is the energy associated with motion. So the classic example is a bike rolling down a hill, has very high kinetic energy, it's in motion. Or the picture we see on the screen are pool balls. So the pool balls that are in motion, those have high kinetic energy. We can also think of kinetic energy as energy being transferred. So when those pool balls collide or connect, energy is transferred from one pool ball to the other. And that also is a form of kinetic energy. So kinetic energy, how do we talk about molecules? We don't really talk about molecules rolling down a hill or bouncing around on a table. When we talk about kinetic energy for molecules or the motion of molecules, we tend to talk about thermal energy. So thermal energy is defined as energy that's associated with temperature. So thermal energy is kind of a form of kinetic energy. It's underneath the umbrella of kinetic energy. So we can talk about the motion of particles in a beaker. So if I were to heat those particles up, they're going to move faster, right? And if I were to cool that sample down, maybe put it in a freezer, those molecules are going to move slower. So that's the way that the position we typically take when we talk about kinetic energy. We're talking about thermal energy, the energy associated with temperature.